Everyone, this is Dr. Resta, and I'll be talking about crack detection of concrete by using a convolution neural network. So, first of all, let me talk about artificial neural network. So, artificial neural network came with the thought of creating artificial machine that can work and have operational process similar to biological nervous system of human beings. So, uh, so artificial neural network consists of high number of interconnected computational nodes, and the purpose of it is to uh, learn from the input, and so that its final output will be optimized. So uh, first of all, the input layer takes the multidimensional data and passes it to the hidden layer, and hidden layers makes a decision based on all the weighted connection provided, and uh, and uh, and gives that to the output. So main goal of the artificial neural network is to uh, improve prediction accuracy of the network by iterating it, iterating it, and adjusting the weight and decreasing the errors. That's it. So next is a convolution neural network. So convolution neural network is a form of artificial neural network that is commonly preferred for images classification, video processing, and yeah, and convolution neural network, it uses the convolution layers, and it 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 the layers extract the local features from the input data, followed by like pulling layers actually downsamples the features, reduce the uh, dimensionality, and um, uses the dimensionality so that it can be passed to the next layer um, with reduced size. So downsampling is it extracts the most important details, and discards the less important features. So mm, there are multiple layers in the model of CNN here. Uh, which is also known as hierarchical feature extraction. So mm, by passing it through multiple layers, the model is able to capture all the complex patterns of the images, and and the relationship between all the input data, and able to provide accurate and precise output. So next is the details about the data. So the number of images for the I've clicked the number of images. So for cracked, I clicked 450 images, and for a non-cracked, I've taken 350 images. And after compiling them together, they are split into 80-20. uh, Sorry, 80 test data and 20 train data. Um, So next is pre-processing of images. So after importing the images to Python, first of all the pre-processing is done. Pre-processing um, converts the images to into data frame. So by using dot globe, the all of the images will be imported, and they are going to be converted to data frame. So for crack df, we use define function processing.df, and then we created data frame crack df, and for non-crack we created that. And after that we concatenated both, that is we compile both of them, and gave random status this, and yeah, and we created next data frame. So after that, the data is after that the images are descaled. Rescale basically change the pixel of data from pixel of images from 255 to from to between 0 to 1. uh, so this is basically done for training set, and as well as testing sets. So next is like generating batches for training data. For that, the size of the image is rescaled into 120 into 120, and color mode is given as red, green, and blue format, and class is given binary because there is only two classes, that is cracked and non-cracked. And for this, I'm given a batch size of 16, and I've shuffled the um, so the shuffle is given true, so that the data is shuffled before each epoch, and set is 42 and subset is this. So this is basically done for a train data also. The next is building a model. For building a model, uh, the first of all the input is provided with the size of 120 into 120, and after that it is passed to next layer convolution layer 2D, where there is 16 filters, that is the images, the model will go through images 16 times. So, and kernel size is given 3 into 3, that is the basically the model which slide through the images into by 3 into 3 size and to across the window, and activation is given ReLU, and input is passed through the second layers, and next is like max pool is given. Max pool basically reduces the spatial size, that is height and length, and but keeps the depth as it is. So next is the next layer consists of filter of 32, and kernel size 3 into 3, and activation this. So here is also max pool is done with pool size of 2 into 2, and next is the layer is passed through the global average pooling, which reduces the dimension of output to single value, that is all the um, rows will be converted into only one. Mm, Basically that happens, and so the output only consists of one dense layer, and activation is sigmoid. So after that the model is built by taking the architecture as input and output as output. So next is model compilation in feed. So the model is compiled by using model.feed, and keeping the training data, and epoch is given as 12 for training data. And next is compilation. For compilation, the optimizer is given as Adams. Loss is binary cross entropy, and matrices accuracy. So summary is printed after that. So this is basically the model architecture, where the first layer consists of 120 into 120, and second consists of 118 and 118, because the last one cannot be um, gotten into the window, so the size of decreases to 118 to 118. So max pooling uh, layer basically the it passes through the max pooling layer, which reduces the size from 118 to 59, and that is basically passed to the next layer, and similarly the next layer does the similar job, and global average reduce the size to 1, and it is passed to the dense, and output is given. So so next is evaluation of the model. So for evaluation of model, the test data is taken, and in defining the from the result, the first value will be the loss, and second will be accuracy. So in that way the model is evaluated. Next is the result. So the result is I've uh, I've done the now modeling for two data, that is for my own data sets and for Kaggle data set. So just so to know that if my data if my modeling is correct or not. So from my data sets, the test accuracy was 67, and loss was 0.62, and test accuracy was 0.65, and loss was 0.62, so which is good. So for next also made RC curve basically evaluates the overall performance of binary class model. It ranges from 0 to 1. 0.5 is random classifier, that is as equal as tossing coin, and 1 is perfect classifier. Here RC curve is 0.71, so it is good. So this is for Kaggle datasets. For Kaggle datasets, the test is loss is 0.06 and accuracy is 98.49. And basically my model is it shows that my model is correct, but the datasets um, are not enough. Thank you.